So here they've given us a function and asked us to graph it. So I graphed it in Desmos. And they want to know what the end behaviors are using limits. So if you remember, when we're talking about limits, it looks like something where we write lim, right? And then usually you have something on the bottom, and then the function stated, and it equals something else. So we're going to look at this graph. We can see where its maximum minimums are. We can see where its zeros are. So we know that we've zoomed out far enough to actually see what its end behaviors will look like. So if we say the limit as x approaches positive infinity, and all that means is we're looking on the positive part of the x-axis, right? The positive domain of it. So if we look at this side of the graph, so we're looking at this side of the graph, we want to know what the end behavior will be for all positive x's. So that's all it means by the limit as x is approaching positive infinity. So if I look at that, I will notice that it is going down into the negative part according to the y, right? So that means that the limit as x approaches positive infinity will equal negative infinity because it's going down into the negative parts of your range or your y, right? So then we can also state the limit of x as it approaches negative infinity. So now we're looking at the other part of the graph, right? Where the domain of this function is all negative numbers. So we're looking at this side of the graph. So what does the function look like once you get to your negative x's? Well, in this case, all the negative x's, you can tell that the function is going up into the positive y, right? So your limit as x is approaching negative infinity would be equal to positive infinity because all the y's for that side go up into the positive.